Welcome for today's class. This is for class 8th Mathematics Quadrilateral Chapter 4 Ganita Prakash textbook. Okay, so in this chapter we will study some interesting types of four-sided figures and solve problem based on them. Such figures are commonly known as quadrilateral. The word quadrilateral is derived from Latin word quadri meaning four side. You can see four-sided figure and letters referring to the sides. You all can see the sides, these lines 1, 2, 3, 4. Quadri means 4. There will be 4. 1, 2, 3, 4. Okay. Now you'll have to observe the following figure. Now this is having a 4 lines. Okay. So this is a quadrilateral. So I will call this as a quadrilateral. This is a quadrilateral. This is also a quadrilateral. This is also a quadrilateral because it is having four sides. When it comes to these two, this is not a quadrilateral because this is a curved side and you cannot put an angle. So there will be a difficulties in putting the angles over here also. This is not a quadrilateral. Only these three are quadrilateral. Remember this. Okay, figure 1, 2, 3 are quadrilaterals and the other are not. Why? Because the angles of the quadrilateral are the angles between its sides has marked in figure 1, 2 and 3. You all can see angles are there, right? So we will all start with the most familiar quadrilaterals like rectangle and squares. Okay, so next topic I will start with the this thing on rectangle and squares in the next class. Okay. So today I'll wind up my class here only. Today we only spoke about the first page. Okay, that is the quadrilateral. Okay, I can even show you all about the rectangle and squares. Okay, moving towards the rectangle and squares. We know what rectangles are. Let us define them. Now, what is a rectangle? A rectangle is a quadrilateral in which the angle are all right angles 90 degree and the opposite sides are of equal length. The definition precisely states the condition a quadrilateral has to satisfy to be called a rectangle. Are there other ways to define a rectangle? Let us consider the following problem related to the construction of rectangles. Next we have is a carpenter's problem. So this is a carpenter's problem is the next topic. A carpenter needs to put together two thin strips of wood. So you can see these are the two thin strips of wood which you can see in this figure 1. So that when a thread is passed through their end points, it forms a rectangle. So when you put the thread inside these end points, what will happen? It will form a rectangle. You all can see here. She already has 8 centimeter long strip. What would be the length of the other strip? Where should they both be joined? Let us first model the structure that a carpenter has to make. The strips can be modeled as a line segment. They are the diagonals of the quadrilateral formed by the end points. For the quadrilateral to be the rectangle, we need to answer the following questions. For example, what is the length of the other diagonal? What is the point of intersection of the two diagonals? Then what should the angle be between the diagonals? Okay. So let us answer these questions using geometric reasoning deduction. If that is challenging, try to construct measure some rectangle. To find the answer to this question, let us suppose that we have placed the diagonals such that the endpoints form the vertices of a rectangle as shown in figure 2. So I will be reading only the deduction 1. What is the length of the other diagonal? This can be deduced using congruence follows. Since ABCD is a rectangle, we have AB is equal to CD. So ABCD is a rectangle. So AB is equal to CD. Means you all know opposite side of what is the property of a rectangle? Opposite side of a rectangles are equal. Okay. Then angle BAD is equal to angle CDA is equal to 90 degrees. So both A and D it is a 90 degree. And AD is the common to both triangles. If we take two triangles, AD is a common. So side, angle and side we have used. So it is congruence to this condition. Side, angle, side. Both the triangles are congruent. Now, therefore AC is equal to BD. Okay, AC is equal to BD. Since they are corresponding part of congruent triangle, this shows that the diagonal of a rectangle always have same length. So the other diagonal must also be 8 cm long. You can verify this property by constructing measures some rectangles. Then also you'll have a reduction to reduction to. What is the point of intersection of the two diagonals? You all can see there are two diagonals are given and you all want the point of interaction. So this is the point of interaction now. Coloring position is there. The blue angles are equal since they are vertically opposite angles. So since angle B is 90 degree, so it will be 3 and 1 I will put. 3 and 1 90 degree both. In order to show congruence, consider 1 and 2. If you show 1 and 2, are they equal? Alternate interior angles you will call them, right? So ABCD is in triangle ABCD, since 3 and 2 plus 90 degree is equal to 180. So they have taken a triangle B, C and D. In this, angle 3 plus 90 plus angle 2. So angle 2 plus this, okay, 90 if you take on other side minus 90, we will get 90 degree. So here what you will get? So angle 1 is equal to angle 2 is equal to 90 minus angle 3. Thus, by the angle side condition for congruence, these two triangles are congruent. Hence, OA is equal to OC and OB is equal to OD, since they are corresponding part of the congruent triangle. So, O is the midpoint of AC and BD. This shows that the diagonal of a rectangle always intersect at their midpoints. Therefore, to get a rectangle, the diagonal must be drawn so that they are equal and intersect at their midpoint. When the diagonal cross at their midpoint, we say that the diagonal bisect each other. Bisecting a quantity means dividing into two equal parts. Then you will have to verify this property by constructing some rectangle and measuring the diagonals and points of intersection. That we will do in the next class. Okay. Can the following equalities be used to establish that this two triangle congruent? So here it is. AO is equal to CO, angle AOB is equal to angle CO2, vertically opposite angle, AD is equal to CB, you can see. We will be doing this in the next class, so don't forget to like, subscribe my channel and share it with your friends. Press the bell icon for more updates. If any doubts, queries, comment below.